Earth Systems 3209. Unit 4, the forces within Earth. References for this unit can be found in chapters 4, 15, 16, and 19, and also in Appendix A and B of the Curriculum Guide. Unit 4, Topic 3.1. This topic will look at forces and factors that affect deformation. We will focus on defining crustal deformation, force, and stress, outlining and describing 3 types of deformation, identifying and describing the forces that cause deformation, and identifying and describing the factors that affect deformation. Let's have a look at some of the terminology associated with crustal deformation. Crustal deformation is associated with internal forces within the Earth. Crustal deformation is defined as the general term that refers to all changes that occur to original rock and the size of the rock body. It may also produce changes in the location and the orientation of the rocks. Crustal deformation mostly occurs along plate boundaries, that is, tectonic margins. And plate motions and interactions along plate boundaries generate tectonic forces that cause rock units to deform. When you're looking at crustal deformation, some of the terms that would reference would be force. Force is anything that tends to put stationary objects in motion or change the motion of moving bodies. And forces are very important when studying plate tectonics, which lead to the formation of crustal deformation. Another term that's referred to when looking at crustal deformation is stress. Stress is defined as the amount of force applied to a given area. And when we look at deformation within the Earth, 2 types of stress is generally referred to. The first stress is called uniform stress. And uniform stress is equal in all directions. A second type of stress that causes deformation is differential stress. Differential stress varies with the different directions. The third term that we look at is called strain. Strain causes an irreversible change in the shape and size of a rock body. The original configuration is not retained during the deformation. So these 3 terms are common terms that are used when we look at crustal deformation. Let's go in and look at a closer look at the types of different crustal deformations. When we look at differential stress, which is stress that is not equal in all directions, we generally look at 3 different types of stresses put on rocks. One type of stress could be called compressional stress. Compressional stresses are stresses that shorten a rock body and are compressional in nature. The second type of stress that could lead to deformation of the crust is tensional stress. Tensional forces are stresses that elongate a rock body. And a third type of stress that is put on crustal rocks are shear stresses. A shearing stress causes sections of a rock body or 2 separate rock bodies to pass or slide past one another. So when we look at the different types of stresses that are put on rocks within the Earth's crust, we see forces that are called compressional forces that cause crustal areas to move toward one another, and that tends to compress an area which will shorten the rock body. So if we look at the original shape of the cube above, and we put compressional stresses on this cube, the rock will tend to result in a shortened body in nature, but it can increase in height. If we look at tensional forces are caused when forces move in opposite directions and elongate a rock body, that is, pull a rock body farther apart. So if we look at the original cube again, we notice that tensional forces applied to this cube will tend to pull the cube apart, thereby elongating the cube itself. And in this case, it'll shorten in height. Whereas if we look at the third type of differential stress, as shear stresses occur in opposite directions. In this case, the shear stress will tend to deform or push the original square to one side, and the result would look like a rhombus. When we look at stresses and effects of stresses on crustal deformation, we can look at the different types of crustal deformation. First, when rocks are subjected to stresses greater than their own strength, they begin to deform, usually by folding, by flowing, or by fracturing. So these are the three effects that commonly occur as rocks are put under stress. They can fold, which generally means to bend. They can flow, which generally changes their shape and size. Or they can fracture, which is commonly called faulting, which results in a rock breaking. So let's look at the three different types of deformation. The first type of deformation caused by stresses is called elastic deformation. And just as the word suggests, elastic deformation is recoverable. It results when a rock deforms, but when the stress is taken off the rock, it will go back to its original shape and pretty close to its original size. The second type of deformation is called brittle deformation. Brittle deformation is permanent. Once brittle deformation occurs, the rock generally fractures or separates and changes shape and size. A third type of deformation is called ductile deformation. Ductile deformation is also permanent deformation. Once stress is put on a rock, the actual rock itself will change shape, where the resulting rock will tend to flow in solid state, and thereby it is a permanent change. So in review, the three different types of deformation is number 1, elastic deformation, which is recoverable. Number 2, brittle deformation, which is a permanent change. And number 3, ductile deformation, which is also a permanent change. Let's have a look at the three different types of deformation in a little more detail. When we look at elastic deformation occurs when stress is applied gradually, and when the stress is removed, the rock will return to nearly its original size and shape. During elastic deformation, the stress is recoverable, and the rock will return to its original size and shape. Earthquakes tend to result from stored elastic energy and as a result of elastic deformation. Once the elastic limit is reached, the resulting rock in which the stress is applied will tend to flow, which is called ductile, or it will fracture, which results in brittle deformation. The second type of deformation is brittle deformation. Brittle deformation results when stress is applied gradually and when the rock's strength is exceeded, and the rock will behave like a brittle solid, where it will fracture and the rock will not return to its original shape and size. So during brittle deformation, the rock is exposed to stresses beyond the actual strength in the rock, and it will result in a fracture, which will not return to its original size and shape. Brittle deformation generally occurs near the surface, where temperatures and confining pressures are lower. And brittle deformation is a permanent type of deformation where the rock will result in fracturing. The third type of deformation is called ductile deformation. Ductile deformation occurs where stress is applied gradually, and when the rock's strength is exceeded, the rock will flow in a solid state and produce a change in the original size and shape without fracturing. Ductile deformation will occur at great depths beneath Earth's surface, where temperature and confining pressure are higher. During ductile deformation, the change that you see in the rock is permanent and is not recoverable. An example will be similar to when you put a penny on a railway track. And as the train moves over the penny, it will flatten it. The metal is permanently changed. Let's look at some of the factors that affect crustal deformation. The factors that influence the strength of a rock and thus how it will deform include temperature, confining pressure, rock type, and time. All four of these factors will affect what type of crustal deformation will take place. The factors that influence the strength of a rock and thus how it will deform include the following. When we look at temperature, the colder the earth materials, the more brittle the deformation will be. Whereas if the earth material is warmer, the more elastic or ductile the deformation will be. So when we look at temperature, temperature influences crustal deformation. In colder environments, deformation tends to be brittle, and in warmer environments, deformation will tend to be elastic or ductile. The second factor that affects crustal deformation is confining pressure. Confining pressure will only result in elastic or ductile deformation at varied depths beneath the Earth's surface. So confining pressure will only influence rocks at great depths because confining pressure is caused by the weight of the overlying rock. So if the rock is located at the Earth's surface, it is not subjected to confining pressure, just directional pressures. Confining pressure will occur when brittle deformation typically occurs on the surface, when there is no confining pressure from above. Therefore, brittle deformation on the surface is caused by directional stresses and not confining stresses. The third factor that influences crustal deformation is the rock type. All rock types can be deformed. However, sedimentary rocks could be more easily deformed since they are softer. So metamorphic and igneous rocks tend to be a little harder and may undergo a different type of deformation than sedimentary rock. So sedimentary rock is a softer rock and is more easily deformed. And the final factor that affects crustal deformation is time. The more rapid the deformation, this tends to result in brittle deformation. The slower the deformation over longer periods of time tends to result in either elastic or ductile deformation. So if rock is deformed rapidly, it tends to result in brittle deformation where it fractures. If rock is put under stresses on a slower, longer periods of time, then the resulting deformation will tend to be elastic or ductile. Let's have a look now at some past questions from past public exams. First question reads, which factors would cause a rock to deform by brittle deformation? So in this case, we're looking at the factors and which factors would cause brittle deformation. So when we look at brittle deformation results from a shorter period of time, and it also occurs when rocks are colder. So the answer to this question would be A. Brittle deformation occurs when stresses are put on a rock over a shorter time, and generally if the rock is in a colder environment. So the answer to this question will be A. Question number 2. Which type of stress and faulting occurs at divergent plate boundaries? So if we look at a divergent plate boundary, we're looking at a boundary which generally moves apart. So the stresses that are put on divergent plate boundaries, where two plates move apart, will be tensional forces. Because the plates are moving apart, they tend to pull the rock sections apart. Therefore, we see brittle deformation, which will result in normal faulting. So the answer to this question will be C. Divergent plate boundaries are generally exposed to tensional stresses, which result in brittle deformation that form normal faults. So the answer is C. Your turn. Take the time and complete the following question. You can pause the recording now to prepare your answer, and the solution will be on the following slide. The question reads, which rock type is most easily deformed by stresses in Earth's crust? Our choices here will be igneous plutonic rock, igneous volcanic rock, metamorphic rock, and sedimentary rock. When we compare all three rock types, igneous rocks, both igneous plutonic within the Earth and igneous volcanic on the surface of the Earth, and also metamorphic rock, tend to be more crystalline. Whereas sedimentary rock are rocks that are put together from sediment that generally has softer cements. So therefore, D, sedimentary rock, would be more easily deformed. So the answer to this question would be D, sedimentary rock. Let's look at the points covered in this presentation. Crustal deformation is a direct result of stresses that is put on rocks. We looked at three different types of stresses, and these three types of stresses include tensional forces. When tensional stresses are put on a rock, they tend to elongate or pull the rock apart. Compressional forces or stresses. When compression is put on a rock, it tends to shorten the rock or compress it. And number three would be shear forces. When shear stresses are put on a rock, they tend to move the rock in different directions, or we can have different segments of a rock which tend to move in different directions. There are also three different types of crustal deformation, and they include elastic. Elastic deformation is recoverable. Brittle deformation. Brittle deformation is permanent. And ductile deformation. Ductile deformation is also permanent. We also looked at the factors affecting crustal deformation, and they include temperature, confining pressure, parent type or rock type, and time. When we look at all the different factors affecting crustal deformation, cold environments tend to deform by brittle deformation, whereas warm temperatures, warm environments, the rocks will tend to form by ductile deformation. When we look at confining pressure is the pressure applied by the rock above. So confining pressure usually occurs in environments that are below Earth's surface, and they tend to result in either ductile or elastic deformation. The rock type, sedimentary rock types, tend to deform by ductile deformation, whereas crystalline rocks such as igneous and metamorphic generally form by brittle deformation, unless they're in a hot plutonic environment which is beneath the Earth's surface, where we also experienced a lot of confining pressure. And regardless of the rock type, if the amount of time is very slow when the stresses are put on the rock, the resulting deformation could be it could be ductile, or it could be elastic. That is, if there is a long time frame where stresses are put on rock, then the resulting deformation would possibly be ductile or elastic. Whereas if stresses are put on a rock over a short period of time, then the deformation would generally be brittle. So these are the different points looked at in this presentation.